So in Logtrust, we're very different from the competition. We don't deal with data models, so we're data agnostic. So since we deal with flat files, our data footprint is really small, which allows us for great speeds compared to the competition. So I'm jumping right into some flight stat data that I have uploaded in time 20 years ago. So it's from 1987 to 2007, flight stat data from a subset of data across the United States.
So these are US airlines?
Yeah, these are US airlines, US flights. So this is the raw data from a month of data in 2005.
Okay.
So if I show you, and then here, let it load for a second. And as you can see, the visuals are very different from standard big data platforms. Instead of seeing a log data really raw, it's a really structured grid view that allows you to quickly, at a glance, understand what's going on. So you can see that, for example, these are the destination or airport codes, and you can quickly do a quick breakdown. And I want to see, for example, all flights going to Atlanta. And I can just click on that and filter, and I've filtered out all the flights that are not headed to Atlanta.
Okay.
And then, right, so a quick click, for example, if I want to see these are negative numbers, that means they left before they were scheduled. But if I want to quickly just show the ones that actually had delays, I can do greater than 0 right here, and you see it's not really, I'm not coding anything, I'm just typing things out, and then it'll show me real quick all the flights that had delay in 2005 on every airline. And then for example, that NA I'm not interested in, so I click enter, and then I negate the value, and then I'm filtering that out. And then let's actually be able to graph this, right? So I'm really interested in graphing the whole thing. So here I can see the destination of the airport, and I'm able to enrich this through a correlation table that gives me the name, the location, the city, the state of the airport. So here I have the origin longitude and the origin destination and the origin latitude as well. So I'm able to get all that information. So here I have the codes and then the latitude and the longitude of each airport. And I can quickly group by that information and understand. Grouping is basically putting that data in buckets to later analyze it, right? So then I can group by real quick here, and I'm grouped by all this information. And inside each of these rows lives tons of information. So for example, all the airlines that flew from Seattle to Atlanta are there. So I can quickly do a count, for example, of right over here, the aggregator, and then I can do, for example, the average delay of all. And I already know that they at least had delay, so I'm already taking into account that they're delayed, because I could also take out of the equation the fact that there were no delays, so it would give me an actual real number, but I really want to know the average when there was a delay, how long that delay was. So it's a different complete metric that we were doing just a delay analysis, because it will also take account into the flights that made it on time or earlier. So here we go. I'm going to find the departure delay and do an average of this. Why are you not letting me? Oh, it needs to be okay, I can fix that real quick. So what I do is actually make that. I create a new column and I make it an integer. So I can create that column. I make it an int. And the great thing about Logtrust is that exploration is really easy. So I'm not having to spend time figuring anything out. Here I have my delay, where's departure delay? And I create a new column called delay int. So I know it's a number, and then I can do operations on it. And then I go back to the operation I did over here, the grouping, and I group it right away. So I don't need to do all that stuff again. And then now I can calculate that, right? So do the same thing, the average. And now I know that my column's at the end because I added it in here. So where is it? My screen needs to zoom out. It's a problem with having screens that are not yours. There we go. Come on. Departure delay int. There we go. I found it by just typing it out. Yeah. And then I have the departure delays that are above 0. And then I can graph this real quick. So, and you can see graphically all that happened too.
Oh, nice. Okay.
So even before you graph, you already have an idea of what's going on.
So what is on the y-axis here?
So the y-axis here are the actual events that occurred, that happened. So for example, if I want to zoom in, here we have a really high frequency over here. I can quickly zoom in at that time period, and now I'm looking just at that time period.
But what is the data? What is it?
Oh, so it's the number of lines in the number of events that occurred over that period of time. For example, Here, this is the November 21st, and that happened throughout all of these hours. So that's what it's representing. And then I want to go back and quickly see the month again, and I'm back here.
Oh, right.
So I can dig in, out really quickly.
It's great that you've got like the data and the chart all in one view.
Right, and then we get into really cool graphs, which is this one's one of my favorites. It's actually destination, and then destination code, and then origin latitude, destination latitude, destination. I mean, I know they're all ending in Atlanta, right? But what gets really cool is when I do, origin longitude, and you can see I can graph really quickly with just click and drag. It's there. I don't need to do any sort of coding or anything like that. So I can just, and the departure delay would be the link of the data that's showing up, and then I'm able to graph this. So I'm going to put this full screen so you get the full effect of this, and then I can put it on my map because I have the latitude and the longitude, and now I have all the flights in 2005, where they were coming from and where they ended.
Since just the delayed flights.
These are all right. These are all the delayed flights, and the thickness of the line represents the width of the delay. So then I can adjust really quickly the node sizes right here because there's a lot of equal ones. So I can do 0.5, and it'll shrink, and it'll show the big one much bigger. So I can quickly adapt the thing, everything is going, and I can make the width of the much bigger. So if I have like a really big departure delay, I can increase the width of it too.
Right. Oh, cool. That sounds cool.
Hey, Greg. So that's kind of one of our advanced visualizations on how quickly you can dive deep into the data. However, this is kind of the exploration mode. The end result really comes from putting all that in like a well packaged output view. In this case, we're doing smart shelf sensors. We're detecting weight in and out of stock. So it's a quick like mat under here, and whenever it goes out of stock, it throws a Boolean value that says it's out of stock, and we receive that data and quickly alert the, for example, store manager of what's going on, and they're able to assess that information and quickly restock that item without having to send someone down to the floor of the store and have someone write the UPC code, then go back in the inventory and figure things out.
Right, okay, so this is a totally separate product?
Correct. This is a solution that we created for a marketing company that's basically wanted to implement this.
Okay.
And we created this. And the real driver value is the loss of sale. So here we're visualizing, it's a lot of kind of going on first. It's 4 months of data here from November 5th to March 5th of this year. And then this graph is showing the loss of sale calculated by the minutes out of stock and the price of the item. So based on the price of the item, every minute it's out of stock has a potential loss of sale. Basically, if it's not available, I might be losing money.
Okay, got it.
So, and here's like a big bird's eye view of what's going on. I can quickly go in and just drill deep, right? So a yogurt lost me $5,000, Chobani lost potentially $3,000, and I'm like, oh, that's interesting. And then I can be like, I want to know more about this now that I'm here, and I just do search detailed info, and it pops everything in the graph. So it does a search on a search.
And does it go like into by store, by?
You can actually, I can split this however I want. I can actually move the departments around, and it'll do an analysis based on departments and stores. So I can really flip things around really easily. And then dig in this way. So I want to know beer. Oh, I lost $11,500 on beer potentially. And then it's mostly in Quickie Mart. So I want to go in Quickie Mart, and then AB lost the most money. So I can go in here and then do the same query right over here, and it'll show that information. These are the top 10 potential loss of sale items. But the really cool graph is this one that I'm talking about right here. So it really gives you a breakdown of all the items throughout the 4 months and when they were out of stock.
Oh, nice.
And you can visually assess, for example, Buddington Pub Ale was out of stock in December 13th to the 23rd.
So this is live right now, this product?
Yeah.
Oh.
So, well, they have a trial running, not a trial, they have a demo running in the sense of they have small data set that they're testing out, and they're still sending live data.
Oh,
but yeah, so this is historical data in the sense, but we also have a live running one. So this is one of the use cases. Since we're data agnostic, the potential is endless in the sense of any type of data can be analyzed this way if found the right use case. And that's what we're here for.
Yeah, I think that's really cool actually. That's definitely got business value.
Exactly, it's all business, right?
It's all measurable, right?
Exactly.
You can say you lost this amount in this month and right.
And you're not even talking to the IT guy, you're talking to the business specific people. So you could potentially take the data scientist like value and add it to anyone that has a business idea or a business question. And you now have that power to make those decisions and that understanding. Before, to do some analysis on big data, you had to go to an IT person too that understood coding or anything like that. With Logtrust, it's really easy through click drag solutions and very low code, and you can see no code, click drag, and just enter, and then you can find solutions that way.
Yeah, that's really cool.
Yeah. And then we have some other examples. For example, here we just finished this one. It's wind farm data across the world, and we're actually running a live simulation on California data. So here we can quickly see on a heat map, geolocated wind farms around the world, and so these are manufacturers. So I can quickly, for example, you can say Gamesa has a high presence in Spain. If I take it out, you can now understand other stuff. And then I can quickly, from here, I can go to the query and see the in-depth data if I really want to. So I can go here and it loads the query automatically. So I can go from a bird's eye view to an in-depth view at a click without having to figure out what that data was.
So
that's what's being graphed, right? And I can quickly then change information here and do a different analysis and then go back to my application. And it's pretty simple to do that switch back and forth, right?
And of course it would do alerts as well.
Right, so the alerts are set in the same fashion as the query. So example here, if I have let's quickly change this. Here I can edit this and I can say, show me the ones that are less than 10, so the underperformers.
Right.
And then I can do all the same analysis, back forth over here, group by 30 minutes. And then I can do a quick count right here, and then do the same analysis. Just these are my breadcrumbs of the analysis I've done, and then I can quickly see everything that I've done right here. And then I have a count right here. So if I want to set a threshold that greater than 5, if they have registered greater than 5, I want an alert based on this. So I can quickly create an alert condition right here.
Got it.
And every time that happens, I get an alert in the system, and then I can email it out. I can send a text out to someone. Yeah. I can send the Jira ticket notifications. Many ways of alerting out of the platform.
Right.
Where we've been mainly showing the in-platform graphical performance, but the capacities outside and integrating with the API and other tools are just as big. Let me show you one last thing. The same thing.
It's come a long way. I used to work in databases, and we used to do, I don't know if you've heard of the product called Business Intelligence. We used to create universes. And we said, oh yeah, this is fine for business users to use, but it's like way
light years ahead. Right.
You still have to go down to the SQL.
Correct. So this, for example, you can understand that like the manufacturer had a problem really quickly, and then be like, oh, what turbine models are specifically giving me issues, and then you can be an operator and address that situation specifically. And even different teams, for example, we can determine if they're offshore, and then do an analysis, because that's a whole different team that you need to send out for maintenance, right? Because it's not the same equipment.
So you can see, how do you see which one has the issue?
Here, it's basically just the offshore ones. For the issue, I can show you really quickly. Let me load that up. I'm just showing something. It's showing a version that I'm working on. That's doing the live version. These are data coming in every 10 minutes.
Right.
And it's actually showing me the last 30 minutes of data live. Okay. So the actual status of the health of each. And then I do a breakdown of the city, the manufacturer, the turbine model.
Right.
So I can quickly understand that these are stopped in Altamonte and San Giorgio.
Okay.
And then I can go in and understand that the manufacturer is Negmicon and that it's running at 6%.
Right.
And I've assessed that's, and then here is the zoom of California and the table breakdown of what's really going on this data. And I can quickly assess in California, for example, I want to see the healthy ones, I take out all the rest and I'm only seeing the healthy ones. But if I want to see the anomaly traffic, that's my anomaly traffic. And if I want to see the ones that are stopped in California, I can quickly, click on here, there we go. So, yeah. Right, and then I can quickly just do stopped here, and it'll show me which one stopped. So I can do a visual understanding of both things.